Good morning, folks. Hi, API World. My name is Joe. I'm a software engineer at Lightstep. Lightstep is a company that helps you understand your systems, particularly distributed systems, particularly serverless systems. But I don't want to talk too much about Lightstep today. I want to talk about strategies for making modern systems observable. So there are a lot of reasons people adopt microservices these days. We learn all of these reasons that microservices are great. You have less coordination costs between teams because teams own a lot more of their own stack. You can put your developers and your operations people close together. They have expertise together. They own gateways. They own interfaces. So you've got a lot of independence within your organization. You can handle more data if you design your systems right, horizontal scalability for given services. There's lots of good carrots in the garden, and there's a big stick. Everything sorts of can fall apart very quickly. This diagram on the left is a real system that we see at Lightstep. It's, in fact, a big part of Lightstep's system. You can just see a ton of edges here. There's a big iceberg, and there's always one service out there somewhere that's falling apart. The developer left, you don't know what's going on in it. So there's a lot of ways that microservices architectures can fail and other architectures can fail. You have big outages. A nice thing about big outages is someone will call you on the phone. You'll know quickly what's down. A database might stop reporting. You might lose routing to the network. Somebody cuts a cable somewhere. There are big causes for big outages. You find the problems fast. But what happens a lot more in complex systems is there are little regressions somewhere. Some data is falling apart. It's slow for somebody, one of your customers, a small customer. Nobody notices for weeks. Sometimes the customer notices before you notice, and they have much smaller causes. Somebody pushes some bad code in one service. It's unreviewed by the whole team. Misconfigurations happen. So you talk to an old database replica that doesn't have the right stuff. These are all things that I've seen in my career. So it becomes really hard to detect these things. Here's one that I caused. Every couple of weeks or so at a job that I had, one of our services would crash with an out-of-memory error. Every couple of weeks, every 3 weeks, every, 2 weeks, 3 days. It wasn't regular. We couldn't really predict when it was going to happen, and it was just sort of like hot in our backlog. This was kind of a problem because this service served multiple things, and somebody would get paged. It was a real pain in the neck. Root cause in the end, a cache in one of the applications was never dropping old entries. Things would just build up and build up and build up, and eventually, it's all gone. So what happened? I wrote some API code for one of our customers to call. It was really expensive to compute, so I cached it, and I wrote my own little LRU cache that I was sure worked right. It didn't work right. And, it took us, weeks of this thing falling apart for us to figure it out. This is like a thing that happens pretty often. I can see a lot of sort of nods and smiles out in the audience. So something that would have helped me find this faster was that calls to this particular API on this particular service often preceded the right? It was just the straw that broke the camel's back and knocked it over. If I had application events about API calls, if I had system metrics about memory and CPU consumption and put them together in the right dashboard, hopefully we could have found this faster. It ended up being a real trial and error sort of debugging situation. So it took us so long because we didn't have knowledge about what was going on in the system, and lack of knowledge is why we can't root cause problems. Observability, it's a hot word these days, but a big part of what it means is designing our systems so we have that knowledge. So we see events coming out of all of our applications. We can put it together in a meaningful way. But most software most of us work with, we don't code it. We haven't changed the design in years. We don't want to change the design. It's already with us, right? It doesn't work for the business for us to spend a bunch of money redoing it, right? That can make it difficult to observe. We don't want to rewrite it. Here's some famous examples from the ancient past of rewrites that fell apart. Um, Netscape 6 sank the company. Microsoft Longhorn delayed a Windows release by 4 or 5 years. Don't rewrite your systems. So how do we fix bad code in our services already? How do we fix problems in services that exist? We refactor it. We go read Martin Fowler's books. We spend time on the website. And we can use those same refactoring tools that we use to fix software to fix observability problems. So what do we want out of a refactor? We want to know when our code is working and when it isn't. And we're going to do that by measuring important things in the application. And we're going to figure out how to explain those measurements and why they change. And we are going to try really hard not to change the behavior of the system. Anything that you measure, you can sort of prod the system into changing a bit. We're going to try to keep the observer effect of doing this really small. That means trying not to add too much CPU overhead to measuring our system, exporting various logs, metrics, trace elements. And we're not going to re-architect the system. We're not going to change the relationship between things. Nobody has time for that, as we talked about. So we're going to approach this through an incremental change, which is the only way in your organization of dozens or hundreds of people that you're going to make anything happen. You're not going to convince a VP to let you do this to the entire system, but you might convince your manager to let you do this to your service. And as you do that, you can demonstrate why this works, and you can persuade your teammates to do it. You can persuade the systems you depend on to do it, so you can explain what's going on in the system that you work on. So about measuring the important things in your application. You may have heard of service level indicators. You should figure out how to define them. A service level indicator is a measurement about your system that is actually important to your business, that's actually important to the people who depend on you. Some really common ones are availability, latency, errors. These are things that actually make differences to people who call you. What it usually isn't is memory load or CPU consumption. These are not things that your customers care about. By customers, I mean people who call the thing you own. It's not going to matter to them. So don't start with that, even though it's easy to measure. So you want to define these for your sphere of control. You want to talk to the people who use your service about them, right? You want to say, this is how you can tell if we're being good to you. And we're going to start our refactoring approach by getting measurements of those SLIs. So our biggest sort of measuring tool, which is related to a refactoring technique of kind of wrapping old code with a good interface, is going to be wrapping system I/O. In a microservice architecture, we have tons of I/O. We have every API endpoint that we publish. We have every disk call that we make. And as we add more services, we get more and more and more edges. Most of your unpredictable system failures happen at these edges between services, much more than they happen kind of inside any individual service. And things that happen at the edges, inputs and outputs, also tell you quite a bit about what's happening inside that box, right? Like, you expect a function to have an input and an output. You expect a service to do something when you call it. So measuring when you call and measuring what you put out is a big first step. And it's a lot more valuable than putting events at random places inside your code. A few strategies for doing this. You can think of your service in a sort of vertical way, right? There's an API, there's a service, there's a database, there's a little kind of net. So start at an edge and work your way down is a strategy that I've seen applied successfully. And another one is, to borrow from the sales world, something we would call land and expand, which is find a service, find a system that this is a good candidate for, and then spread out. And a bit about the order of operations that we would want to take here. Start with external APIs, start with things people call. These are usually where your SLIs are, and wrap those. You've got maybe a framework You've got maybe a proxy or an API gateway. These are great places to start instrumenting. Start at the first level of code that you have control over. Maybe even this is a RPC framework or HTTP server framework that you have. You can often insert things like interceptors in these that will export telemetry data, measurements, things like that. After that, wrap calls down to things you depend on. This will let you tie calls that come in to calls that go out from a service that you own. And that'll give you a big part of what's causing changes in your system, right? You may see increased latency downstream from you, which explains why your service is slowing down. You may or may not see increased errors downstream from you that explain errors. If you don't see them, well, then you know to look inside your service. And if you do see them, then you know who to call. And you know who might be on the hook for your pager going off. After that, start talking about storage or databases that you own locally. That's another good place to start seeing errors happen. I think it's important to re-emphasize here that we're talking about external things, not internal to your code. I see a lot of people that I talk to saying, okay, I'm going to instrument this function call, then I'm going to export some metrics from this function call, then I'm going to export some metrics from this function call, all the way down inside my service. And I'll have every number that matters, and I'll be able to explain everything. And that might be true in your service, but you're going to spend a lot of money, as in time, making this happen. I mean, it's going to be difficult to measure the return on that if everything is just within a little local team's problem. So it's a really good investment to spend your time at the edge. Some best practices, some kinds of data that are useful in this case. These are things we know about. Logs, metrics, events, trace elements. A big problem with actually making this stuff useful, making it explain things, is inconsistencies in format, things that make it difficult to query. So structured logs, make sure that the logs that you have coming out all follow a common format that you can grep or you can parse into some other system. JSON is a great structure if you use the same fields all the time, but even just a log line that always starts with a severity, a timestamp, and a message. A severity, a timestamp, and a message every single time will get you a long way from here's a big file, good luck. For metrics that you export, keep them application-specific metrics or keep them host-level metrics. The best events to export are, latency measurements, counts on calls, and counts on errors to calls. Structure metric names hierarchically so you can find every metric for a given service. It's great to name your metrics service.api.success, service.api.failure, so you can easily group these and connect them to each other. Really similar for events and traces. Keeping them at a high level and keeping them meaningful to people who look at the system, who look at the outside edges of the system, people who call you, and keeping them very judicious. Over-instrumenting is a big problem in observability because let's say you have an API call, you're likely to have an order of magnitude, potentially more events inside a given call, right? You may call 3 or 4 services, they may call 1 or 2 services, and all of a sudden you're at 10 events for every API call. So it's important to try to keep yourself below that, or at least keep yourself around an order of magnitude more events. Otherwise, you'll find that your logging and telemetry data is more and costs more to store than your actual application data. And suddenly we're in a place where, sure, you can operate the service, but is it worth it? Are you running a negative margin on your system? So doing all of this is about making things that used to be invisible to us, measurable to us. And as I just mentioned, there's a lot of data involved. So, we have to send all of this out of our application through instrumentation libraries. You might use something like OpenTelemetry, which can provide you like a log sync, a metric sync, and a tracing and event sync kind of out of the box. It runs as a little sidecar next to your service, and it's a nice standard way that you can sync stuff into storage. So you've got to send it out. It's an awful lot. Now you have to store it somewhere. Oh, it's an awful lot, and it's expensive. And now you have to query it. It's a lot of stuff. It gets complicated very, very quickly. And we need strategies for dealing with this part of the system too. So we have the data. I want to make some recommendations about measurement and explanation tools. There's great open source things that really help in here. You know, Kibana is a great front end over a lot of this kind of stuff. A really important thing about building dashboards and building paging systems, orient around application functionality, whether that's across, you know, a vertical stack or within a service. Orient your dashboards around functionality, around APIs, not around like one service. When somebody's on the hook upstream from you, it should be easy for them to kind of follow the trail through and see what measurements are directly correlated with what measurements. If you've made 5 dashboards and your ops team needs to know about all 5 and they need to put 4 windows on the screen and maybe one in the middle over at the top of the dashboard to see what's going on, now you have a sad ops team. And if you're a modern company, now you have a sad dev team, because guess what? They're the ops team. This will help you correlate measurements that affect each other. But there are also tools in the marketplace that can help you make these correlations automatically. You should invest in those because they help you tame that sea of data very, very quickly. There are, you know, statistical engines. There are vendors that you can buy from. There are, you know, tools that can help you even just make educated guesses, right? That just observe kind of what I would call just out of whack, right? Line graphs. It doesn't even need to be terribly, terribly complicated. Yeah. So a quick recap of where we've gotten. We want to, you know, we all work with services that we don't control. We all work with services that we didn't build, and we all work with services that are difficult for our teams to understand. So look at edges in those services and look at ways that you can export important things from those edges, defining important things up front and ruthlessly prioritizing those important things to measure is extremely important to success in a microservice architecture. Getting some of those things automatically out of proxies, out of sidecars, even just sort of like local API gateway management things is very, very valuable. You want to minimize your effort to output here. And it's really, really important to invest in tooling that helps you understand that data as it comes out. I would recommend, well, of course I would recommend my own company, but I would also recommend looking into open source standards like OpenTelemetry that can help you have a systematic approach to putting these things in a useful place. It's local data, it can be in a vendor cloud, but the important thing is to keep it organized and structured. And that's all I have. Thanks very much.